Hello everyone, my name is Sanjeev and today we're going to be looking at SAT Math. Today we're going to actually be looking at geometry and trigonometry, and we have area and volume, and we have 5 difficult level sums. So let's start with question 1. Question 1 says square A has side lengths that are 166 times the side lengths of square B. The area of square A is k times the area of square B. What is the value of k? Okay, so what do we know about squares? One sec. So pretend this. Oh wait, that was terrible. Let me do this. Okay, let's make it smaller. So this is not going to be a perfect square, but just pretend for a sec it is. Oh well, this is about as best as I can draw. But say you have the side length of A. Remember, a square has both sides. Sorry, let's say it's the side length S. Okay, say both sides. Remember, a square has all 4 sides of equal length, right? So we know the area will be S times S, or S squared, right? So we say square B has a side length of S, right? And say that means that square A has a side length of what? It's 166 times the side length of B, so 166S, right? So what do we know about our values? We know that it is, for the areas, it is B is equal to S squared for the value of our area. And for A, it would be 166 S squared. If we simplify this part out, we get 166 squared times S squared. So, and that is equal to B. Remember, and it's asking what is the value of K, where K is, the number of times the area of square B. Well, the area of square B times K is equal to the area of square A. So that means that K is actually equal to 166 squared. Which you can then plug into the calculator to find out that K is equal to, let me put it into my calculator. Okay, yeah, 27556. And that is what K is. And that's how you solve this question. This one was more of an easy one, even though it's still technically under hard difficulty. It's just being able to figure out, how do you figure out what the area of a square is? Okay, this one is a bit more difficult as it deals with volume and not area, right? So it says the circumference of the base of a right circular cylinder is 20 pi meters, and the height of the cylinder is 6 meters. What is the volume in cubic meters of the cylinder? Okay, so first we need to think, what is the area of a cylinder? What is the volume of a cylinder? So the volume of a cylinder is pi r squared h, or pi times r squared times h. So we have the circumference of the base of the cylinder. So the circumference is equal to 20 pi. So how do you figure out what is the circumference? Remember, the circumference is 2 pi r, right? And that is equal to 20 pi. So dividing both sides with pi, we get 2r is equal to 20. That means that r is equal to 10. And we already know that the height of the cylinder is equal to 6. So now we have all that we need to solve this problem. So volume is equal to pi times r squared, which is 10 squared, which is 100, times h, which is 6. So that is equal to 600 pi. And that is option choice C. Moving on to our next problem. Oh, and then this one was a bit of like a double-layered problem. We had to figure out what is the radius using the circumference, and then only can you find out the volume. So in this sort of situation, it's always important to identify and create like a roadmap of what steps do you need to solve in order to get our final answer. Anyways, moving on to our third question, it says, the figure shown is a right circular cylinder with a radius r and a height of h. A second right circular cylinder, not shown, has a volume that is 392 times as large as the volume of the cylinder shown. Which of the following could represent the radius r in terms of r and the height h in terms of h for the second cylinder? Okay, so what do we know? So again, our volume of a cylinder is pi r squared h, right? So if say your original cylinder has this as its volume, then our largest cylinder, our second cylinder, will have a value of 392 pi r squared h, right? Because we know that the volume of our cylinder is 392 times as large as the volume of our first cylinder. So now what we need to do is figure out if we substitute in 8r or 8r, 7r, or 49r, or whatever value here in for r, and we do the same thing with h, which one of them will have 392 as a coefficient? So how are we going to do that? This is a bit of a plug and chug type method yet to use. So you have 8r as your radius now. So 8r squared times times 7h pi. Okay, and then that would be equal to, oh come on, yeah, and that would be equal to 64 times 7, which, if I'm doing my math right, is equal to 42. Wait, 1 second. 448 pi r squared h. So this is obviously not equal to 392 pi, right? So what we need to do is try our next one. Oh, actually what we can do is, we already know that A is wrong, right? And why? It's because the value is too large. So if you look here at part B, we see that R is equal to AR again, but our H is equal to 49H, right? So what that means is our volume will actually be even larger than our first one by a factor of 7. So that means that it will be even larger than A, which is already larger than what we need. So we can immediately eliminate B. We can move on to option choice C next, and we have 7R and 8H. So this would lead to 49 times 8, which is 6, 72, 392 pi r squared h, which is our answer. Because remember, that's the constant that we need, 392. And that's how you solve this problem. I wish I could say there was an easier method to solve this, but for this one, all you kind of can do is plug and chug until you get the right answer. Moving on to our next question, we have rectangle ABCD is similar to rectangle EFGH. The area of rectangle ABCD is 648 square inches, and the area of rectangle EFGH is 72 square inches. The length of the longest side of the rectangle ABCD is 36 inches. What is the length in inches of the longest side of a rectangle EFGH? Okay, so there are multiple ways you can solve this problem, but I'll be teaching you the easiest way. So the easiest way depends on the understanding what is a similar rectangle or a similar triangle or similar anything. So a similar rectangle means a rectangle that has the same proportions. Wait 1 sec. Wait, let me try something here. Yeah, has a similar proportion as each other. For example, here we have Oh, wait, that was... So if you have a rectangle here, this one, and then this rectangle, if they have the same proportion of sides, then that means that they're similar rectangles. And you might be asking, well, what does that mean? Say you have a length of x for this side, and a length of y for this side. And then say you have another rectangle that has a length of 5x on this side, and a length of 5y on this side. That means that they are similar rectangles. Now, when I mean proportionate, that means that the coefficient has to be the same for both sides. So it has to be 2x and 2y, or 3x and 3y, so on and so forth. It cannot have a different multiplication for the lengths of each side. Okay, so and another thing we know is that if you say that this is side A, and then this is B, this is C, and then this is option D, side D, not option D, then what will happen is, if you have another rectangle that is similar to this, for example, if it's just larger, say that rectangle is this one right here, then E, F, G, H. This might seem kind of confusing, but what I'm trying to get at here is that the angles are corresponding. Okay, so if you look here, if I can get this to work, but if you see here, A is our starting angle and E is our starting angle, and they're both in the same corner, right? B is the second angle and F is the second angle, and then both of these are in this corner. So on for C and D. And this is the same thing if you rotate it. If you rotate this rectangle around, the angles are still going to be the same no matter what. You can tell. So now what this has to do in significance for us is that it says the length of the longest side of ABCD is 36 inches. So say X is equal to 36. So that means that E and F is going to be the longest side in our other one, right? Well, this is assuming that AB is the longest side. If AD is the longest side, then EH would be the longest side in your other rectangle. All that is wait one sec. Yeah. So all that is to say is our area of rectangle ABCD is 648 inches. Right? And the area of rectangle EFGH is 72 inches. Right? So we know that they're proportionate. So 648 is just some number times the area of EFGH. And remember, if it's X, if it has X and Y, then the length of ABCD would be like 2X, 2Y. Okay? So that means that it will be a multiplication of 4. This might sound confusing, but say you get 5x, 5y, right? And your original was x and y. So that means that you'll get 25xy. So what we will be having is the square of the length that you're multiplying the proportionate or the sides by. So 648 divided by 72 is equal to it's equal to 9. Oh, I forgot the division. Yeah, this is equal to 9. So 9 is 3 squared, right? So that means that ABCD has 3 times the length of EFGH in all sides. Okay? So the longest side of ABCD is 36, right? So 36 divided by 3 is equal to 12. Okay? So our answer is 12. And the reason I went in this kind of like long tangent is for you guys to understand that when you're multiplying, when you have a similar rectangle, when you have like a similar rectangle, your area is going to be the square of your side. It's going to be the square of the sides. Well, not the sides, but like, I guess what I'm saying is if you have xy and you're multiplying both sides by a certain number, your area is going to be increasing by the number squared. That might really sound really confusing, but just a bit of practice and you'll be able to get that. Okay, moving on to the last question. If I haven't jumbled up your guys' minds already, it says the floor of a ballroom has an area of 600 square meters. An architect creates a scale model of the floor of the ballroom, and where the length of each side of the model is 1/10 of the length of the corresponding side of the actual floor of their ballroom. What is the area in square meters of the scale model? Okay, so if our one sec. Oh, yeah. We can just assign arbitrary values for each side of our ballroom. So 60 is the total area. So that means that the sides of the ballroom could be 10 and 60, right? It doesn't matter. So this is our ballroom. So each side of the model has 1/10 the length of that. So you have to divide both sides, both our lengths by 10. So 10 divided by 10 is 1. And 60 divided by 10 is 6. So this will have a length of 6 for our area of the square model. That's how you solve some of these area and volume problems. I might have confused a bit here, but all you need to do is kind of practice to figure this out. I tried to teach you some tricks here. If for example you didn't understand how to do the previous question to this one, all you really have to do is do the simpler trick. Well, not simpler. You just need to find out what is the area of rectangle ABCD and divide by 36, and you can get the length of both sides of ABCD, and then you can figure out the proportion of both sides of EFGH. Okay, and that's all I have for you today, and have a great day.